Hi there, folks. Thank you for joining me. We're going to be starting another Waterloo Math contest in this series of videos. We're going to be starting the Hypatia contest. That's the grade 11 written solution required contest, and it's going to be the Hypatia from 2010. So just like the Friar and Galois, the Hypatia is great practice, especially if you plan on writing the Euclid in the next couple years, because the Euclid, very similar setup, written questions, written solutions to the questions are required, and these contests are a little shorter, they're a little lighter, but they still give you wonderful practice. So, as I say, 2010 Hypatia is what we're going to be looking at, and like with the Friar and Galois and all the other past Hypatias and all future Hypatias so far, there's only going to be 4 questions, and I believe we get 75 minutes, although I will have to check on that at some point. I do encourage you guys to download a copy of this contest, try the contest out first. That is the best way to practice. Okay, it's how we practice writing on our own without watching someone else, without getting external input. How do you naturally write? And it also lets us identify gaps in our knowledge. What types of questions do you find you get stuck on in that 75 minutes? What things are you quite quick at? Okay, what things do you think you're quick at, but then you come watch these videos and, oh, I should have used much more words when I was writing this up, that sort of thing. Okay, so you can click the first link in the description, get a copy of the 2010 Hypatia, and try it on your own. I will, as usual, be doing 1 question per video, so we're going to dive into it with question number 1 here. Pyravina must make a trip from A to B, then from B to C and C to A, so we got a triangle over here. Each of these 3 parts of the trip is made entirely by bus or entirely by airplane. The cities form a right angle as shown at C, and we've got a distance of 3,000 kilometers here and 3,250 kilometers up here. To take a bus, it costs Pyravina 15 cents per kilometer, and to take an airplane, it costs Pyravina a $100 booking fee plus 10 cents per kilometer, or $0.1. I guess we'll keep it all in the same units. So $0.15, $0.1, that's fine. Okay. So we've got 3 parts to this question. To begin her trip, she flew from A to B. Determine the cost to fly from A to B. So she took an airplane, A up to B. So, well, how does flying work for her? She's taking an airplane. It costs her $100 booking fee plus 10. I'm going to keep saying 10 cents. $0.1 per kilometer. Okay, well, we know how far she needs to go. So that's 3,250 kilometers. So we can plug this into an equation. Let's get our notebook. There we go. So, to fly from A to B, which is 3,250 kilometers, it costs $100 plus $0.1 times the distance that she went. Well, that's just going to be 100 plus, and the 0.1 and the 0 will cancel out. It'll be 325. So it's going to cost her $425 to fly from A to B. Okay, not that hard. There wasn't a whole lot to show there. If you wanted to, I guess you could keep units, kilometers here, and this one's kilometers here, and the units will cancel out. But no one who's marking particularly cares about keeping units straight. Hey, it's 1A. There's not a whole lot to do here, but we took the method of flying and how that cost is calculated, and we correctly identified from A to B is 3,250 kilometers. Not a whole lot to go with there. Okay, B part. Determine the distance she travels for her complete trip. So here's where the right angle triangle part's going to come into it. We have the length of the hypotenuse. We have the length of one of the legs. So by Pythagoras, we can figure out BC. So the distance she travels, so the distance Pyravina travels for the whole trip is AB plus BC plus CA. Now we have a right angle triangle here, 3, 2, 5, 0, 3, 0, 0. By Pythagoras, or by Pythagoras' theorem, depending on what you want to say. We know BC squared plus CA squared is equal to AB squared, but we can rearrange that to BC squared is equal to AB squared minus CA squared. That's 3,250 squared minus 3,000 squared. Okay. And, well, we could break out our calculator, or we could probably try and find, I'm fairly certain there's a common factor here. Take out a factor of 250 and you will get 12 here, and take out a 250 you will get 13 here. So that'll be 250 squared times 5 squared, and that'll be 5 times 20, so it'll be 1,250 squared. So BC is going to be 1250. Of course, we can check that on our calculator. Now, the thing that annoys me when I make these up is this isn't the year where they've introduced the standard cover sheet, so I genuinely can't remember if we're allowed to use calculators. I'm fairly certain we are, because I seem to recall on these contests I've had to approximate things before. But that's an important thing to double check before you write any contest. Our calculators are allowed. Our graphing calculators are allowed. That sort of stuff. And I'm fairly certain calculators are allowed, so I'm just double checking this on my calculator. And yes, I am correct. Okay, good. But it's important to have the skill to be able to sort of recognize factors, and this is probably going to have Pythagorean triples in it, just in case you are stuck without a calculator. Either you forgot one or you're not allowed to have one. Okay. So the distance, Pyravina, is there an H in there? Nope, okay, I got it right. So the distance she travels is 3,250 plus 1,250 plus 3,000, and the 250s will become a 500. Nothing gets carried. We'll have 1, 3, and 3, so it'll be 7,500 kilometers. Okie dokie. So that's the total distance she travels. A to B, B to C, C to A. Just like they describe in the question. Okay. So we'll flip the page because we've got C part left to do. So Pyravina chose the least expensive way to travel between cities, and her total cost was $1,012.50, or 1012.5. Given that she flew from A to B, so they're telling us that that was the correct decision for her, determine her method of transportation from B to C and her method of transportation from C to A. Okay. So now we need to start thinking, okay, does she bus from B to C? Does she fly from B to C? That sort of thing. And I'm betting, because B to C, we calculated that was 1,250 kilometers. That is so much less than either of the other two. They're both in the 3,000s. I'm betting it's probably going to be cheaper to bus from B to C, because I think it's not long enough to make up for the savings you get to outweigh the cost of the $100 ticket that she needs to buy. But there's a real quick way to calculate this sort of stuff. Okay, there's going to be a certain distance that we can calculate. Maybe we'll call it D or something like that. And we can calculate whether or not it's better to take the bus over the airplane. There'll be some value D where they're both equal. And if you're less than D, you should be taking the bus. If you're more than D, you should be taking the airplane. That sort of thing. So that's what I want to calculate now. That way I can quickly characterize, does she bus here or does she bus there? Does she fly? Where does she fly? That sort of stuff. So I think you could either do that, or you could, for each one, calculate the fastest way she should travel. So you might ask yourself, should she bus or fly from B to C? And you'd get two calculations. You'll just take the lower of the two. And that's fine. That's a great way to do it. You wouldn't lose any marks, but I want to be a little fancier. Okay. So consider a distance d. We're flying and busing. Busing just have one S. English skills, don't fail me now. No, I think you have to have the two S's, because otherwise the U would say its own name, because it would go vowel, consonant, vowel. So yes, busing should have two S's. Cost the same. As soon as I find this D, for any distance less than D, she should bus. Any distance greater than D, she should fly. And if you want to, you could put in some argument as how you know it's got to be the lesser distance that becomes the bus. Any quick comment about how the $100 fee doesn't change will indicate that the bus goes to the lower distance. Anyway, such a D well, if the two costs are equal, then we have to have 0.15 times the distance is equal to 100 plus 0.1 times the distance. That's 0.05 times the distance is equal to 100. And now this is 5 over 100d is equal to 100. Of course, we could also write this as 1 over 20. And so multiplying through by 20, we get d is equal to 2,000. So if there's a distance that's exactly 2,000, it doesn't matter whether or not she buses or flies. It will be the exact same cost. Specifically, it will cost her $300. Okay, I didn't calculate the $300. I'm just looking at the equation. I can do that in my head. Okay, so that's our special distance. Now, anything less she should bus. Anything more she should fly. Okay, well, we've got two more distances for her to go. Now she's got to go from B to C and C to A. Notice that we can now see her choice of A to B flying was correct because this is more than 2,000. In the same way, C to A she should fly because this is more than 2,000. Now, we just want to determine her method of transportation. We do know her overall cost here, so we could double check at the end. But we're not actually asked to show that this is the amount she travels. The amount she needs to pay to travel. But we can just jump back in. So B to C is 1,250 kilometers, which is less than D. So she should bus. And then C to A is 3,000 kilometers, which is more than D. So Puravina should fly. Okay, and these are the two things that they wanted. You could even, if you were writing it, highlight it a bit. Okay, and as I say, I'm going to do just a little extra. I'm going to calculate and make sure that we do have the right cost. So 1250 multiplied by 0.15 plus 100 for her flight there, and 3,000 times 0.1 plus 100 for her original flight, and then 3,250 times 0.1, and I can just quickly bring out my calculator. 1250 times 0.15 plus 200 for both of the initial cost of the flight tickets. plus 3,000 times 0.1, plus 3250 times 0.1, and we do indeed get 1012.5. So we just do a little double check. If this number that we calculated down here came out to be something other than the free information that they gave us, I mean, we didn't actually need this information here, we would go back and double check. Does our analysis make sense? Did we calculate D correctly? Is our understanding of how D works that less than buses and more than means fly? Did that make sense? Okay, this is just an extra double check. We don't have to do it. They didn't ask us for any of the costs, but it's something we can do. Okay? Just for our sanity. So, in the next video, we're going to take a look at question number 2, and then question number 3, and then question number 4, and we'll be done. If you haven't already, download the contest, try it out for yourself, try question 2 before you get to the next video. And speaking of which, I will see you guys there for more of the 2010 Hypatia.